Hi, folks. In this section, we're going to talk about solving quadratic equations using square roots. And some of you have been trying this on your problems so far, but one thing that you kind of missed out on is that when you take the square root of something, there are actually two solutions. There's a positive solution and a negative solution because uh, uh, positive 4 times positive 4 is 16, but negative 4 times negative 4 is also 16. So if you take the square root of 16, the answer isn't just 4. It could be positive 4 or it could be negative 4. And this is an important thing to remember. So we're actually kind of devoting a whole separate section to it. We're going to learn how to solve quadratic equations that are written in the form x squared equals d. So this is written as a perfect square. So you can take the square root of both sides of the equation. And we will find that when d is greater than 0, this equation has two solutions, two values of x that solve the equation. If d equals 0, there's only going to be one real solution, x equals 0. If d is negative, if d is less than 0, then there are going to be no real solutions to the equation. You'll learn in Algebra 2 how to deal with those imaginary solutions, but for Algebra 1, we're just going to give the answer no real solutions. So let's look at some examples and how to deal with those. So we're going to solve these equations using square roots. And what you'll notice about each of these terms is that, even when they're written in standard form, there's no b term to these quadratic equations. There's a coefficient in front of the x squared term, and there is a constant term, but there's no x term in here. That means kind of b equals 0. So we can take this equation and we can solve for x by just rearranging the equation, kind of doing reverse PEMDAS order. I'm going to add 27 to both sides of the equation, so I get 3x squared equals 27. And then I'll divide both sides by 3, so I get x squared equals 9. And now that I know that x squared equals 9, I can just take the square root of both sides of the equation. I get that x equals. Now let's pause for a moment. Up to this point, people who are trying to solve square roots this way would just give positive 3 as the answer. But remember, we need to do plus and positive and negative versions of this. So we're going to have plus 3 and minus 3. So we'll have, x equals positive 3 and negative 3. And you can write it either way. You can write it with the plus minus sign in front of it. As the solution to the quadratic equation. So this particular quadratic equation has two solutions, positive 3 and negative 3. Let's look at another example. Here, I can add 10 to both sides of the equation, and I get that x squared equals 0. That means when I take the square root of both sides of the equation, and remember, I want to have a positive solution and a negative solution. Well, that means x is positive 0 or negative 0. That doesn't make sense when we're talking about the number 0. 0 isn't positive or negative, it's in between. So in this example, we only have one solution for x. X is just 0. In this third example, we'll subtract 11 from both sides of the equation. We get negative 5x squared equals 5. And then we can divide both sides of the equation by negative 5. And we get that x squared equals negative 1. And if we try to take the square root of both sides of the equation, you cannot take the square root of negative 1. If you try on your calculator, you will get an error message. As I said, in Algebra 2, we'll learn how to deal with the square root of negative 1 and how to kind of deal with imaginary numbers. But for now, we're just going to say that there are no real solutions. So you can see if your x squared equals a positive number, you're going to get two real solutions. If your x squared equals 0, you're going to have one real solution. And if your x squared equals a negative number, you will have no real solutions as your answer. Now, Couple extensions to this rule. First of all, this polynomial is, well, this is written as a binomial squared term. If you can write a polynomial as a perfect square, you can take the square root of this whole side. If I take the square root of x minus 1 squared, remember, if you take the square root of any term squared, that just equals x, the term that you square rooted and squared. So here, if I take the square root of both sides of the equation, sorry, 25, the left side of the equation is going to give me x minus 1. So x minus 1 equals the square root of 25. Well, the square root of 25 can be positive 5 or it can be negative 5. So what we're going to have here are two separate equations. Either x minus 1 equals positive 5 or x minus 1 equals negative 5. And we can solve both of these equations. We can add 1 to both sides and we get that x equals 6. Or we can add 1 to both sides and get that x equals negative 4. These are both solutions to the equation. If D is not a perfect square, you can use technology to calculate the square root using your calculator. Just remember, you do need to have a positive answer and a negative answer. So let me show you what I mean. If I add 13 to both sides of the equation here, I'm going to get that 4x squared equals 28. Well, I can divide both sides by 4, and that's going to give me x squared equals 7. So now I can take the square root of both sides of the equation, but I'm going to have a positive value and a negative value. So x is going to equal the positive square root of 7 or the negative square root of 7. But if I need to know approximately what that value is, I can just type in the square root of 7 on my calculator, and then I'll know that x is going to be plus or minus positive or negative 2.65. And get an approximation that way. All right. So how can we use this strategy? Are there any real world examples where we might use this? The answer is yes. If you want to find the volume of a rectangular prism, which is like a box that's rectangular shaped, you can multiply the length times the width times the height to get the volume. And if the volume is length times width times height, and I know that the height is 3 feet, and I know that the length is 3 times its width, so the length is the same thing as 3 times W. So I'll plug in 3 times W there. And then the width is just W. That all works out to be 270 cubic feet. So I plug in 270 for the volume. And I can attempt to solve this equation. On the left side, that just stays as 270, but 3 times 3 is 9, and W times W is W squared. So I can try to solve for W by dividing both sides by 9, and I get that W squared equals 30. So now I can take the square root of both sides of the equation, and I get that W equals plus or minus the square root of 30, which I can plug into my calculator and get an approximate numeric value for. W can either equal positive 16.4 feet or negative 16.4 feet. Now, although mathematically both of these solutions are true, they both work out, in the context of this real world problem, one of these solutions doesn't make sense. You can't have a negative width in a box. You can only have positive measurements. And so the only answer that makes sense for this particular story problem is positive 16.4 feet. All right. A useful skill to be able to do is to be able to rearrange an equation to solve for a different variable. So, for instance, if you want to know the area of an equilateral triangle, where the side length of the triangle is s, you can use this formula. Area is the square root of 3 divided by 4 times s squared. But what if I know the area and I want to solve for the side length? I want to be able to rearrange this equation so that it solves for, so that you can solve for s directly. So whenever you solve for a variable, you go in reverse PEMDAS order. So you take care of addition, subtraction first, then multiplication, division. So if I've got a equals the square root of 3 divided by 4 times s squared, I want to take care of any multiplication division I have first. And a fraction, multiplying by a fraction is kind of both multiplication and division. I want to get rid of the 4. 4 is in the bottom of the fraction, so I'm dividing by 4. I want to get rid of the 4 by multiplying by it. And here I want to get rid of the square root of 3. I'm multiplying by the square root of 3, so I want to divide away the square root of 3, like this. So I'm going to do the same thing to both sides of the equation. I'm going to multiply by 4 and divide by the square root of 3. So on this side, the square root of 3 and the square root of 3 cancel away. Um, uh, Multiplying by 4, dividing by 4, that makes the 4 cancel away. And I'm left with s squared equals a times 4 divided by the square root of 3. Um, Now, I want to solve for s, not for s squared. So I still don't have s all by itself yet. It's got a square symbol attached to it. So what I need to do is I need to take the square root of both sides. And when I do that, I then get a final answer of s equals the square root of 4a over the square root of 3. Now, is this written in simplest terms? No, it is not. But it doesn't really matter if it's written in simplest terms or not, because we are going to, in the next step, plug in a value for a and um, just use this equation on our calculator to calculate the final answer. By the way, only positive, technically we should have a positive and negative sign here, but only positive values are actually going to make sense in the context of the problem. All right, so the next question says the area of the traffic sign is 390 square inches. So what is the side length? So I'm going to use the formula that we just produced. We're just going to take the positive square root, 4 times 390 divided by the square root of 3. So I'm going to have the square root of 1560 divided by the square root of 3. And if you plug all that into your calculator, you will get that the side length is approximately 30 inches. And again, only the positive answer makes sense in the context of this question. So super important to remember that whenever you take the square root of something, you have a positive solution and a negative solution, and you need to take both of those into account, particularly if it's a math problem as opposed to a real world problem. With real world problems, typically positive answers are the ones that make sense. I hope this helped.